Okay, today Yufan will introduce this on grammar preserving rule embedding. So there's a way to to learn a code representation for the code representation to given a source code. Yeah, so this is a shorter paper, but I suggest every of us can raise questions to Yufan. Also, we expect that Yufan will have a few questions for the audience.
Okay, so it's published on IJCAI 2020, and these are the others from Peking University, and there are 5 others, and I think we have read many papers of these 2 professors, and they are all researched in software engineering, code generation task, and I also find a paper also published by these others. And this paper, the Treegen, it introduced a new model called tree-based transformer. And in that paper, it also introduced the grammar. So typically, what is the grammar? They just introduced Python ST. And in this AST, you can see that there are several rules based on the AST. The first rule is the root module. The second rule is module body, and the body assign target value names, name ID, and ID length. So they just define these are the rules of the program language. In this paper, they only introduce the Python grammar. So typically they seems split the idea into 2 papers. One is for module, the Treegen, and
So
another
when you're giving the presentations, would you please more specify on the problems? So since it is model, it's more like representation learning problem, right? So could you tell us the input and output of the model?
I mean, this is the model for a transformer. So the input will be a sequence and the output will also be a sequence. And you can also add a softmax or fully connect layer to be.
So here the problem is that, so let me clarify. So given the traditional transformer architecture, so the input and output are sequence to sequence, but usually the input sequence have some grammar rule, right? Or grammatical rule, like the input could be a programs, or could be a regular expressions, or could be a command line, so which have to follow certain rules. And assume that we have already known certain rules, and how do we embed the rules or take the rules into consideration so that the transformer can learn about these rules, right?
Yes. So now I just introduced the AST tree because I don't know everyone knows AST tree. So for the AST tree, so these others introduce a Treegen because AST is a tree. So if you want to embedding a tree, you better not use the sequence transformer. You can use the tree-based transformer for this paper. So I just give you the background. And I also said that in this paper, these other also introduce the grammar because they think that the ST contains some grammar that we didn't, utilize this information. So in this paper, these others are want to utilize the grammar information. So they think there are 2 grammar information. The first is the structure relation between the grammar rules, and the second is the content information of the rule definition. So you just look at the picture. For the left side, this is the S tree of the code, and for the right side, you can see the upper square is grammar, and it shows the content of the grammar rule definition, and the distribution. The next picture, it shows the relationship between these grammar rules. And this paper said, because I also didn't learn these grammar rules during my learning of Python. So this paper said, for example, for the rule 4 if and the rule for 4, these are the child of the rule 3. This is body for the if was assigned. So they think that the body will have some children, and these children will be if or for or assign statements. And this also the rule 4 and the rule 5
So
also
here is more like a context-free grammar. So both Java and Python can be described with such a context-free grammar.
yes.
So this is more like a production rule. So if we want to have the root, we need to define the module. If we want to define module, have to define the body. So layer by layer. So but at the end of the tree, or at the end of this rule expansion, there will be a terminal and a non-terminal, or will be terminals. So here, so if we say there's the parent node there, each parent node corresponding to a non-terminal nodes in the rules, and each leaf nodes in the left, it corresponding to a terminal tokens. So basically, that is a descriptions for, that is a context-free grammar descriptions for many programming languages. And also, in terms of the language theory, programming languages are usually the context-free language, and for our natural languages, it is usually called as a contextual grammar.
Yes. So in this paper, they mainly want to utilize these two information. The first is the structural relationship between the grammar rules. And the second is the content information of the rule definitions. And here is the module. They just use the Treegen, this Treegen model in this paper. So in this module, that's introduce how they integrate these two information. First, there's a grammar relation graph. So they use the GN to encoding the graph. Second, there is many content, the rule definition of the this grammar. So they add another embedding layer. They first embedding all the rules and then goes to a definition encoding layer. After the gating layer, they use the GN to do the neighbor encoding. So these are the others how to integrate the raw information. So finally, they get the grammar vector because they just run several iterations of the GN, and then this new grammar vector would enhance the base model. The base model is the Treegen base model. So
Treegen base model.
Yes, this model they introduced in this paper. So typically,
so here, so do you have the specification of what the tree generation model looks like?
Yeah. I have a picture. So I first want to say that typically they want to integrate two information. The first structural relationship, they use the GN. The second content information, they just use definition encodings. That means it is a transformer model. So these are the two new parts to integrate the information. And for the base model, they use the Treegen. The Treegen is typically there are three inputs. The first one is the natural language description. The second is the code. The third is the query. So typically, this is the model introduced in this paper. They want to.
Where is paper published?
It is published in. Let me check. I didn't check the paper.
Yeah. So here on. I know this is a Sunday, and some of us were absent for today's meeting. But since you have joined us, especially for the undergraduate students or someone not familiar with this natural language based model, so you can raise any questions, and I think we have enough time to have a thorough discussion, especially if I have only maybe less than 10 slides. I think we have enough time for a thorough discussion.
It is published in AAAI.
Okay, published in AAAI. Okay.
Yeah.
2 years ago.
Yes.
Okay, so all right, so let's look into this tree generation. Anyway, so it seems to me that this each Kai paper is more like have a graph-based embedding before fitting into this Treegen architecture.
Yes, so papers they want to emphasize the tree, the graph information. So typically they introduce this kind of.
So let's look into Treegen. So because that is a base model, right? So Treegen is a base model, and that rule encoding part is what we want to enhance this Treegen, right? Hello, do I miss anything?
Yes.
Okay, so you can move on. Yeah, so let's talk about this Treegen framework.
Treegen framework, we didn't talk about that because it's in this paper. I didn't read the details of the Treegen model.
So you cannot describe, you cannot explain some details, right?
Maybe you can ask, we may have a discussion, because I think it's just similar to the traditional module. They just
So here,
yeah.
so okay, so this is for what kind of tasks? For code
Code
summarization,
generation.
the code generation, and the input is the natural language description, or more like a requirement, a specification, etc., right?
Yes.
And the output is the code.
Yeah, I think so.
And here, so the AST reader, and how do we look into the AST reader and decoder? So if I understand it correctly, NL reader and AST reader are the input. Or when it's input. So here, just as you mentioned, the task is for code generation, right?
Yes.
And here, and how do we look into this? Seems that the encoder part is both NL reader and AST reader.
Yeah.
And the output is the decoder, right?
Yes.
And here, how to interpret the parasites generated code, the rule sequence generated code, something like this.
These are the the rule, because these are not.
Hello, yeah. So do we miss Yufan, or this is part of is problems of my network? Chen Hian and Zhang Yi, are you fine to hear Yufan's voice?
Yeah, I think Yufan's
a bit interrupted. Yeah.
Okay.
Yeah, sorry, maybe my network is not very stable. Could you hear me now?
Yes, so now your voice is a little smooth. Yeah.
Okay, okay. So typically they introduce the rule. I mean, the middle part, the rule sequence is not the concrete code. It's a rule. I mean, this is just the structure of the code. So they want to generate this structure of the code. And the input is the natural language description and the grammar rules. Yeah.
So okay, so I somehow clarified it. So so somehow I kind of understand the details. So maybe anyone could explain or ask any questions. So I think this Treegen is foundations. So it's good that Yufan provides these slides so that we could better understand why or what is the motivations for they propose this Grape architecture. So maybe since we have some time, so maybe anyone or Nimishas or Chen Hin, so do you have any questions or confusion on this structure?
Not from my end, Professor.
Okay, so maybe I try to explain a bit. So the overall idea is that so if in the traditional sequence generation or the language generation tasks, we just want to generate a sequence of tokens, right? So if we focusing on translate from English to Japanese or to Chinese, so whatever it is, so the output is basically a sequence of tokens. But if we talk about the task of code generation, we can look into the code as a sequence of tokens. However, the code need to conform certain grammar rules, right? So if we want to generate a Python code or Java code, so if there's a for, there must be, if we start a for statement with a left parasize, and we hope that we can generate a right parasize, right? If we start with a statement declaration, we want to close the statement definition with a semicolon, right? And if we start with the definition of string, we want the string to have two quotations in the left and the right. So how do we ensure such a grammar information when we are generating a piece of code? So that is a problem the Peking University team is trying to solve, right? So in this case, the input is natural language descriptions, but also we want to the model be aware of the grammar rules they try to follow. So in this case, the input is two parts. The first part is the natural language descriptions as a traditional model, what they're doing. And then the second input is the grammar rules. So basically, it is more like AST description or the syntax description of certain language. This description could for Python, Java, C++, C#, etc., you name it. So by combining these two inputs, and the model will able to generate a sequence. Basically, this model, this decoder is not going to generate a sequence. It's supposed to generate an AST tree. So AST means abstract syntax tree. So it will generate a tree, and then we'll have a way to interpret the tree into the code. By this way, we will be able to always generate the syntax, the code with correct syntax. All right, so is there any questions for this description? Okay, if there's no such any questions, so let's move on. So here the challenges. So the second component, just Yufan showing in the tree architecture, there is the rules. So in this model have to be a way. We have to have a way to embed the rules, right? So in this case, what is the best way to embed the rules? That's why they propose this technique. Right?
Yes. Okay, so now we go.
No. We don't go through data set. We still talk about a bit about the grammar. And would it be more specific? So here is the grammar relation graph, and there's the context, so embeddings, and how do we, how the embedding looks like, right? So we need to, could we be more specific? So basically, when you are responsible for this when you are preparing these presentations, since Triple AI is still a 6-page presentation, I think you need to read both papers and to have a more clear for why, because it is still very unclear, and how the decoder generate a tree, and especially how the rules will be selected and how the rule will be used and embedded. So that's also unclear to us.
You mean the Treegen or the current model?
Treegen, I mean the Treegen. So how in this paper they embedding the rules?
So I think because in this paper they use the graph structure. So here they just input as a sequence. They didn't do anything new to the rule. They just input the sequence of the grammar to the model. In the paper,
I think since you haven't prepared these ones, I think I just a little bit feel that we haven't gone through the paper thoroughly. So maybe we can extend the discussions in next week.
You mean I just read this?
And combine and integrate all of them. So I think this is a very important step for us to understand how the state-of-art work to generate code, right? The code, definitely, the code generation is a tree generation instead of the token generation. So I definitely support these views, and this is very inspiring and definitely the way to go. So for this fundamental technique, how do we follow their technique? And it seems to be a little bit complicated. So the question is whether we need so complicated structure, right?
I think it's not complicated. It's just, you can read this 3 module. The first module is natural language. It's just a transformer. You can see the self-attention, the gating, and the convolution. So this is
so why we need attention of the rule sequence? So why we need attention of rule sequence? It's understandable that the descriptions we want attention for that, but why the rules and the representation is more like the AST representation, right? The root is consists of few modules, and one module is consists of few if statement and bodies, something etc. etc.
Okay,
right?
I may
Yeah.
read the details because I
Right.
just glanced the paper. I didn't read the details of the paper, of this paper. So maybe
Yeah, you can
next.
see there's the tree convolution, right? So there's tree convolution. And what is the inside of designing such a tree convolution, and why there's an error tension? And this error tension, how do we, and why there's a tension layer to combine the natural languages and the output of the gating, right? So, and also for rule sequence, how long it is. So if it is a description of AST, for Java, it is a huge number of rules there, and whether we need to consider them all, right?
Yes. I may read the details of the paper.
Yeah, there are so many questions for us to address. Let's move on. So let's talk a little bit about these grammar embeddings. Yeah.
You mean the grammar
Yeah,
embeddings?
and
The grammar
also,
relation.
yeah, and for now, there's no specific requirement, right? It's pure graph. It's the pure grammar, right? The input is the grammar definition of a specific language.
Yes, yes.
Mm.
So the idea is maybe simple, but the structure is a bit complex because for different code, there will be different relation graph.
And here the question that if we want to generate a code, how do we know which grammar we want to use? So if it is for Java language, right, there's a superset of the language syntax, the grammar syntax. And how do we pick a specific rules to use, or we use them all?
I think they use use all because I didn't see.
But for a special language, for example, C++, they have hundreds of rules to define their syntax. And whether the transformer are
use some
complex enough to include in all of the language, all of the rules.
I don't think they include all the rules. They
Okay, if
use
they do not
part
include the
of
if they do not include the rules, and how do we? Yeah. But anyway, let's move on. Yeah.
Okay, so because in the paper they said the original time is about 30 seconds, and after you use the GN mode, the only time the time is 34 seconds. So there are only 4 seconds. I think it's not quite complex, high time wasting.
Yeah, another
In
explanation
the paper
is
they
that
just
another explanation for code generation, the input is still a sequence of natural language descriptions. For example, we're saying that it will generate an Excel generate. So the description is how do we generate on a quick, how do we implement a quick sort, or how do we implement a bubble sort on array of maybe string, right? And it is sorted by the string length, etc., etc. So if given a specification and feed into model, and the model will infer what syntax to use to generate the code. So these embeddings is basically some internal structure. I don't know. So things you find is not has not prepared the tree generation, I think we can have more thorough discussions. But for now, you can just briefly describe the grammar. How do they embed the grammar? And basically, they want to learn the relationship between the grammar, right?
yes. They want to learn the.
And here, can you briefly explain the node 1, node 2, node 4, and why there's the loop between 3 and 4?
You mean the embedding of the embedding layer, the embedding
I mean
of
the grammar
grammar.
relation graph, the grammar relation graph. And here, and can you briefly describe?
Grammar.
Hello?
For example, the ID 1 is the root module. Hello, could you hear my voice?
It's still
Hello.
it is still a little bit interrupted, but you
Oh.
can go on.
First, you can see there are 8 numbers. The first ID is corresponding to the first grammar, the root module. So you can see the second node is child of children of the first
Mm.
node. So
I see.
they
So what's the
just use
relation?
this kind of relation.
The relation more
Only
like
the-
consistency, or okay, I got it. So
Yeah,
here
yeah.
the node is more, each node is a rule, and the rule will have the relation, and the age basically is the decomposition relation, right?
Yes.
Right, you can see, so 4 actually point to 6 because 6 is a definition of always, right? And
Yeah,
the if is basically consists, or is basically composed by the test body orices, right?
Yes.
So they have this relation, and when they have these relations, we try to propagate the embedding grammars. Okay, so and that's all.
Yeah, that's all. Because
Quite fairly straightforward each kind of paper, right?
Yeah. And
So
I don't think there are many grammar. I read that this typically are about
no,
10
definitely
grammar.
they're no, it's definitely not 10 grammar. If it's 10
Okay.
grammar, so which means that input for the model is only 10 samples, right?
What 10 samples mean? I mean, for all the samples, for the training data set, they are all the
The
same
point is
grammar.
that the training samples. So since input is a rule, right?
Yes.
So giving a specific language like Java or Python,
Yeah.
there are at most hundreds of rules there. Maybe 1,000,
Okay.
1,000. So if there, which means that the training data set is 1,000, right?
No. This is for code generation task. So for all the data set, you mean the data set is the code, is the natural language?
So what I mean is that how do we learn the embedding of the rules, right? And this embedding network is still a neural network model, right?
Yes, but
And the input is a rule, right?
all the rules.
Yes, so all the rules
For all data sets, for all sample in the data set, there will be input all the rules, all the grammar. This is a graph. And
but what's the
this
difference?
graph
But
is
what's the
same.
difference? But what's the difference? So suppose there's a body consists, there's a rule saying that the body consists of if and for assignment, etc., right? So there's such a rule, and whatever the language, whatever the code sample it is, they still form the same rule, right?
Yes.
And which
yes.
means that since the input of the model is a set of rules, so which means that the dataset is small.
But the data set is the code and the natural language pair. It's not the rule. It's not the
No,
grammar.
the point is that the input for this model is rule, right?
Yeah, so for every sample, they put all the rules into the module.
Okay, so let me ask this one. What is the input of this model?
This model input all the rules.
All the rules, and how many rules are there?
Each step, they put all the rules into the module and then do the graph, graph.
So it's more like a code training, right? It's more like code training.
Yes.
But the number of rules is very limited.
So final predictions is fixed because there's no new rules, no new grammar. So they just use the embedding of this. Hello, could you hear me?
Yes. So where are you? You're still at home, or hello?
Nowadays,
Where are you? I'm asking.
I don't know why. I'm in my dormitory.
You are in. It's you not
My
in.
home.
It's not campus. It's not in campus.
Yeah, not in campus. I'm in my home.
Yeah, maybe you can change the network because it's very very stable. And when you give the presentation to all of us, and all the audience will listen to you, right?
Okay, I'm watching
Yeah, so can you still hear me?
Hello.
Okay, yeah, so you're back.
Okay, okay. Now I change it to my phone network, the 4G network. Could you hear me now?
Yes, we can hear you.
Okay, okay. Could you see my screen?
Yes, I can see the screen. Yeah,
Okay.
so here the question, so this is so more like the, for example, what to vector, right? So this is more like a rule to vector.
Yeah,
right?
yes. They just said based on the idea of word embedding.
Yeah,
They
so
just
so
embedded the
here,
rules. Yeah.
so here is the rule to vector stuff. So not like the word to vector. There are a number of words to learn, right? But there's a very limited number of rules, and these rules is learned together with the code generation task. Am I right?
Yes, yes.
But anyway, so the dictionary rules is small, right?
Yeah, maybe one. You said 1,000.
Yeah,
Or-
I think at most 1,000. For Java, there's no such rules, right? No much
Yes.
rules. After all, the AST node is the number of the AST node types are very limited.
Yes, yes.
Mm.
But they train based on the code generation task. So for each code natural language pair, they train once. So there's no concern about the grammar numbers. The only concern is how much the code natural language pair. I mean, it is based on the code generation task. So for example, if there are 10,000 samples in the code generation data set, it will train 10,000 times. So
Mm.
there's no relation to the grammar numbers as from my perspective.
So is there any training tricks? So for example, we pre-train for a while, then the embedding has been fixed or frozen and no need to update it anymore.
Yeah, I also think so. So for the final prediction, there's only 4 seconds increase. Or if it's not, it will, waste
Yeah,
much time.
So in this case, I think we're just touch a marginal contributions of the general picture, right? So the basic idea is about the code generation, and here it's more like incremental contribution to learn the embedding rules to further facilitate the code generation tasks. So maybe
Yes.
let's move on to see if there are any qualitative examples for us to digest.
I think no. There's only 6 pages, and here is the data set. They test their results on 6 data set, and here is the experiment. You can see that there's many experiments they didn't do. It's quite weird because in the table, almost half of it there's no result, and generally their baseline is GPT-2 called GPT, and their original Treegen. So these are 3 modules they tried to compare. Though he lists many baseline models, but they didn't, they didn't compare on the code generation.
No, the problem is that this is a technique which improved the Treegen, right?
Yeah.
So of course it have a name called the Grape, but the technique of Grape can only be applied to the Treegen. So from my personal perspective view, this is more like Treegen plus.
Yes.
Right.
Yeah, I think so.
So the next question is about metrics. So I think Dr. Xiaoyan has just come. So we also have discussion of the metrics. So they're still using blue score or some other
accuracy. Yeah, accuracy.
So how do they define accuracy for code generation?
If the same string, the string.
So the same string, okay.
Yeah.
So how
Okay.
about blue is original blue or blue?
Code blue or something like it, right?
I think it's the original blue.
Oh.
They didn't say this is code blue, so it is original blue. And they also do a TSNE for all the rule embedding, and they said that similar rule.
Yeah, we should do this similar. We should have some similar idea when we submit our XC submissions.
Yeah, I think
so. We claim that the embedding will be closer, but right. So, well, if it's not successful, let's also move on to if our each XC paper reject again, so it's time to recycle it to the next each Kai, right?
Yeah.
Yeah, all right. The time flies. Time flies.
Okay.
Definitely, we need to work hard for the other topics. Yeah.
So this is all the information from this paper. It's quite simple, and I didn't see much, much details about the.
Yeah, I understand. So, which means that Ichikai is a good venue where we can propose solid incremental work based on existing work, right?
Yeah, yes.
So if you look into this work, this is more like Treegen ++, and their contribution to learn the rule there, right? And as for Xiaoling's work, I think Xiaoling is still in Vienna, and probably he leaves Austria to somewhere like France and Italy. But anyway, our Ichikai paper this year is more like DVI++. So we have a visualization technique, and we want to change some of the component to improve the existing one, right?
Yes.
So here, but yeah. So anyway, so Ichikai still a good conference, and this work is overall interesting, and publishing these. I'm not sure whether the term of incremental contribution is proper, but definitely it seems to me that it's borrow a graph, a grammar relation graph, and further improve their technique. Wow, so I think that's enough of my comments. Is there any students who have any questions here? Chen Hing, do you have any question?
Yeah. Slide 5, right? Sorry, I'm quite new to code generation, but slide 5, they talk about structural relation and content information. Is it like
Yufan, will you please go back to slide 5? Yeah.
Okay.
Control and data dependencies?
It's not control data dependency. It's basically a description of syntax. Oh, by the way, for NUS so for both Chen Hing and Zhang Yi, have you learned the compiler principles before?
I've not.
And how about Zhang Yi?
Neither do I.
All right, so maybe I have a brief description of the compiler. So the let me write something here. So if you do not get this point, you may miss the whole discussion. So the overall idea is that when we know that for programmers we're writing high level language, right? The Python and Java. We have the text version of for while, and we have definition. Basically, we write text of the function, right? But the point is that how does the machine interpret those course code into a runnable, executable program, right? So that is so. Despite I'm the researchers in software engineering. I published paper on XE, FSC, etc. But I think compiler up until now is still the greatest inventions in terms of software engineering. You can think about it before invention of compilers, all the programmers have to write a binary code, right? We write opcode, we handle the machine stack, but after the compilers, the programmers only need to write a textual source code instead of handle some very detailed work there. So the compiler, so basically I just write a compiler. But of course, now the Python we call it interpreter, but it is something similar to compilers. It is source code. Source code to the binary code, right? So, but in order to make the machine understand the source code, so the source code information have to handle, right? So we have to define some rules and grammars for how do we write a source code. So that is a topics of the programming language design. So there's a topics, maybe I think there's researchers and professors in US like Prof. Jackson Jaffa. So they are the programming language researchers. They're going to learn or invent new programs. So we have Java, we have Pythons, and we now have the Ruby on Rails, right? So, but what is the next languages, and the science and theory to define a new programming language? So that is research here. But whatever the new language has to be invented, we have to define the syntax. So the syntax basically a tree. For example, we define a code like int a equals to 1, right? So definitely it is the rule, the syntax indicating that despite it's a token, but the syntax, there's the syntax for this representation. So if we can pass this grammar into a tree, so we can say that this code, this piece of code is more about assignment. So there's a rule about assignment. And this assignment have the left part and the right part. So the left part is basically a variable declaration, right? We decline a variable a here. So we have the left part, and we have a value 1 on the right part. So it's more like this variable declaration, and this is more like constant. Or it could be a variable, right? Suppose a is equal to another variable x. So it could be a constant. And for this variable declaration, we can further define the variable declaration is a type and a name or a variable name, right? So which means that a piece of code can be passed into a tree like that. And semantically, this piece of code is semantically equivalent to this tree. So in this work, in contrast to generating a sequence of tokens, and they try to generate such a tree representation. Once the tree, an advantage of the tree representation is that as long as the tree representation is correct, we can always derive the code with correct syntax. Have I made myself understood? So here the AST is basically tell us what is syntax looks like for a specific programming language.
Oh, I see. But sequence can also represent a tree, isn't it? Like we do like in order traversal.
Of course. So you mean the language token, right? I
Yes.
mean the tokens in the natural language, definitely. So in NLP, there's also a syntax tree, but there's the syntax tree in natural language is a little bit different from the syntax tree from the programming language. So in the linguistic, there's the distinguish between the context-free grammar and a context-relevant grammar. Maybe that is 10 or something like that. And for programming languages, so we're using context-free grammar, such as AST to define it. And for natural language, it basically is a context-relevant grammar.
Oh, I see.
Okay, so but the takeaway is that so given a program, there is AST. The AST is basically a syntax to describe the source code. And here in this work, it is basically an encoding of AST rules instead of the code itself. Okay, is there any other questions? Johnny, do you have any question?
I think for the model itself, I don't have a further question, but may I just ask, so maybe it's more about the context. So the problem, the Grape and the Treegen aim to solve is to generate code.
Yes.
So what kind of code? Is it generic?
It could be generic, but based on the architecture, it could be either Python or Java, or some programming, some other languages.
So the aim of the Treegen, like the vision of these models, is to generate source code based on some very generic purpose or this,
based on some very generic description. For example, you want to generate a quick sort. So the input is quick sort, and the model trying to generate the syntactically complete code to fulfill this implementation, to fulfill this requirement.
Okay. So for example, is there any motivating example, like what will after the models are trained, what is the brief high level description look like? And what will the source code look like?
It's more like the Copilot, right? So do you know about the Copilot?
Not really.
The compiler is you write something, you write some descriptive word like I want to generate Excel. I want to generate automatically generate the Excel report based on certain table, right? The table is installed in maybe MySQL. So here you just give him the description and it will generate the code for you. At least a skeleton just there.
Okay. Then yeah, I guess I get the problem now. So no further
Yeah,
questions.
I just want to say that Zhang Yi should raise the question maybe 20 minutes ago. So otherwise, so based on her question, I just can infer that she might be lost the majority of our discussion. So that's not good. So if you have the problems, you have to have a very clear picture and have a very clear view on what's the problem we try to address, right? So that is so if you do not understand the problems, how do you involve the discussion of the solution, right? Okay, so so here the takeaway is another takeaway for a future discussion is that if you do not understand, just try your best to interrupt, and that is fine. And then you know that we have undergrad students, we have PhD students, we have research fellows. So everyone understand the problem different level, but we hope you will not be missed, and you will not get lost during the discussion.
Yeah, I want to ask one thing.
Okay.
So we know that some languages share some kind of they have similarity between rules, right? So for example, maybe we can try kind of using the embedding in one language to generate code in another language, or just to check how similar they are, for example. For example, we can
yeah, that is a very interesting point. So maybe that's a question to Yufan. So I try to phrase Kushit's question. So here, so when we are trying to generate a code, there's no specific requirement that it has to be Java or have to be Python, right? And it is Java because we're using the Java training data, and it is Python because we're using the training data set, the Python training data set. So here, is that possible that we include the rules of multiple languages? So which means that we using the data of both Python, Java, Ruby's on Rails, C++, and we feed all the rule there. So by this means, whether there's any influence on the model.
I think for different language there will be some similar rules. Maybe this will
And especially especially so here you can see I think this is a very insightful, very interesting question. So here the graphical representation of rules is intra language, which means that this rule is relevant to that rules because the Java define that, right? And Python define that. But just as Yufan mentioned, so if there's a rule in Java and if there's a rule in Python, and how do we build their connections? So that is a very interesting, it is still kind of interesting topic.
Yes. Then you can do a transfer learning for different language, maybe from Java to Python like this.
Yeah, but I think if that is the case, we need to enumerate all the rules, right? So because each rule will have its index.
Yeah,
right?
we may manually check all the rules.
Each rule is more like a word in the dictionary. So if we want to say this word is more similar to that word, or this rule in Java is more similar to that rule in Python, we need some way to define that. But I think we can also have some manually defined rules for the adjacent graph, right?
Yes.
Okay. All right. Is there any questions for this presentation? Dr. Chen, do you have any questions? Or Mengyue, do you have any questions?
Yeah, since I come a little bit late, so yeah, no, I don't have any question. Maybe
Yeah, this is just a 6-page paper, so it's very short. Yeah.
Yeah, after I come me.
So we're halfway gone.
Yeah.
Okay.
Sorry,
And how about
yeah, I
okay.
forgot the
Yeah,
same
but no
one.
worry, no worry. So the next week's plan is that you find we're going to synthesize both the triple AI work and the Grape work, and we rephrase the whole idea.
Oh.
Despite it takes some times, but that things you found, hopefully you find can quickly convert to the code generation task. But anyway, that's the way to go.
Oh, so previously Yufan did, I remember is common.
Yeah, he is working on the comment generation, but I hope that he can move on. I hope that he can in the future move on to the code generation. Yeah.
Yeah, but indeed, but the thing is also very crowded, right?
Oh, definitely very crowded. Yeah.
Okay.
And how about Meng Yue? So do you have any question?
I think I have the same question as you mentioned before about the number of the input data. Yeah, because I think maybe the rules are small. And
yeah, the number of rules are very small, but you find address this question, right? So it's more like a combination of co-training. So the graph is just here. On here, I think it is a very interesting application of graph neural network model. And yeah, so it's trying to learn a good embedding. So as long as the structure is there, or the relevance is just there, the semantic relevance is there, the graph model can be co-trained with existing task like NLP translation task to learn the embeddings.
Yeah, but I think the graph should be directed, right? It's a directed graph, not undirected graph.
Yes, it is directed graph. Yeah.
Yeah, but I wonder how can GNN solve this? Does this model use some directed graph neural networks?
So this question for you, Fan. So I think this is a straightforward graph GNN, right?
I don't remember this. I don't think so. I think they just use traditional
Oh, yeah.
I think traditional GNN, because the node is not large, right?
Yeah, but I'm just curious about the direction. And if the
so
graph
they didn't
is
consider the direction. They just think this is on direction. Yeah, I think they didn't talking about the graph, the direction.
So I think maybe if you like, you can look some directed GNN to further improve this model or business idea. And
that's good. That's a good point. So but the contribution here is more like software engineering contribution instead of the but anyway, so we can discuss more of this offline.
Okay. Thank you.
And Kushal, you have a question?
Yeah, that might be a very simple question, and it seems to be a bit off topic, but I'll ask it because I'm curious. So the question is, we are talking about code generation. Can we teach neural networks for like a bit higher concepts like modules and packages or maybe classes? Because we can ask a neural network to make the code of a quicksort, but what if we ask something like make an model view controller, similar stuff for some specific case, and it should generate kind of classes and maybe modules instead of like generating the implementation, and the like more details added by more detailed specifications later, but maybe kind of high level requirements may help us to generate.
That is very interesting. Yeah, that is a good question. So yeah, it is possible. It is possible. So, but the point is that now the Treegen is going to generate the AST, right? So which means, but in this case, you were saying that the output is not, it's still supposed to be a graphical representation, but this is more like a modular graph representation, right?
Yeah.
So telling about what is a controller and where the control, whether we need a controller, we need a UI component, and we need a underlying the data manipulation layers, right? So this is more like architectural generation instead of the specific content generation.
Like learning patterns of the design, let's say.
Yeah, that is interesting. But the point is that the data collection is very tough.
Yeah.
So which means that for now, the training data is very abundant. So we have hundreds and hundreds, thousands, tons of thousands, maybe hundreds of thousands of the training data to generate the content. But in this case, if we want to have a number, which means that we need tens of thousands of projects, or at least design patterns to do this. And data collection will be a very challenging component here. But definitely, it's a very insightful and very interesting question.
Yeah, thank you.
All right, I think we have I think we have enough questions. So anyone would like to raise any questions? Okay, so if no questions, let's thank the speakers and call it a day. Thanks everyone for the attendance.